All right, so we are looking at synthetic substitution and synthetic division, and really the main thing, this is going to be synthetic substitution. I'm just going to do one good problem with you. This is going to be division. All right. So looking at this, synthetic substitution is super helpful when we have something like this. We have f of x is equal to, let's say, 3x squared plus 2x minus 8. We have this situation where we just have a function, in this case a quadratic because it's the second degree, and we want to plug in x is equal to 3. Okay, x equal to 3. We can use synthetic division, which uses the coefficients and our constant, and it uses our x value to figure out what our final value is. It's really amazing how it works out. The way we set it up is I'm going to put my 3 in the box like so. I'm then going to look at my coefficients, and first off, are all these terms in descending order? They are in descending order, right? 2, second power, first power constant. If I was missing one of these terms, I'd have to put a 0 as the coefficient for that term. But in this case, we are not missing any terms. This is the second power, coefficient is 3. This is the first power of x, the coefficient is 2. And this is just our constant, negative 8. You see, so all I've done is look to my terms, see that there's nothing missing, so I just put my coefficients out there, like so. Okay. Next, we're going to put a line here. We're going to make a little box. What we're going to discover is, as we do this process, what ends up in the box is the answer to x is equal to 3 for this function. Okay. So the main thing, there's a few steps. Step 1, drop that 3 all the way down. Next step, we multiply 3 times 3. Okay. We always add down, we multiply off that balance. Okay, I think of it, racquetball comes to my head, I don't know why. If that helps you, we add down, and we multiply to get the next one, 33. So what is negative 8 and positive 33 give us? 25. So what I just discovered was, for this function, f of 3, when I plug in 3 for x, I don't even have to work all that out. I use the coefficients in synthetic division to find that my answer to that will be 25. Who likes that? It's nice when it works, right? Because what if we had something really hard where this was like, 20x to the 5th, there was an x to the 4th, 3rd, 2nd, 1st, 0. You'd have to plug in so much. This way, we just use the coefficients, and these numbers mean something different. They mean something else when we get to division, but for now, with substitution, this is the number. That's our answer. It's like star that out. Okay, the answer to plugging in 3 for x, synthetic substitution gets us there quick. You can do this really fast. This always works. So from here on out, if you don't like plugging this in, this would have been 3 times 3 squared plus 2 times 3 minus 8. It's a bunch of steps, right? 3 times 9 plus 6 minus 8. You would have to do that out way more, greater number of steps. So let's try substitution when it works. Okay. All right. Next, we're going to do division. I want to use all this space, so should I give it a second? You guys have this time. We did this one, so I'm just catching up because it didn't record Wednesday. All right. Next step, when we have this, we have, let's go x squared plus 5x. This one everyone should work out with me because this one is a bit trickier. All right, we have f of x is equal to this fraction. It's division, and we're going to use synthetic division in order to find it. We're going to use the exact same process. So the process that we did, drop down the first term, multiply, add, multiply, add. We're going to do the same thing, but our answer is going to have a different form, a different answer, because we're dealing with this whole big expression here. Okay. So looking at this, the one thing I need to remember is that this is called the divisor, and that is x minus a. Now, since it's x minus a, what is my a value in here? It's tempting It's okay if you get it right or wrong.
2.
2. The answer is 2 for this because the divisor is always in this form. It's always in this form of being x minus whatever the a is. If we ended up with x plus, then I would know that my a value must have been negative 2. But in this case, it's x minus a. It's x minus 2. So my a value goes here. My a value goes here. 2. Right? Looking at our expression on the top, are there any terms that are missing? No? I mean, is it in descending order purely, right? Squared, first power, constant. So I'm just going to bring those values over. My coefficient for this is a 1, right? Then we have a positive 5. We have a negative 10. Let's go ahead and do that. So if you want to try that on your own, it's kind of fun to do it. You can do it in your head too if you want to play. Yeah, let's see. So if you're not sure, write this as quick as you can, and we're going to drop the 1. That's step 1. And we're going to bounce the 2 off that 1 to get 2 times 1. We're multiplying. Get 2. We always add straight down. 7. And then bounce it. 14. Carson, what's the answer? 4. Okay. Now before, if this was, we were plugging in a value of 2 here, then we would get our answer 4, but this is synthetic division. So this is the next step we have to do. So for 1, we're going to end up with the quotient. And then over here, we're going to end up with the remainder, which is that number 4, over the divisor, which is the first thing we were dealing with, the divisor. So I already know the remainder over the divisor. That part's pretty straightforward. I know that that is going to be 4 over what we started with. Okay. The remainder part is just the divisor on the bottom that we started with, and the 4 on top. Now we want to go after the quotient. So the quotient, I'm just going to give her some of these lines here, because the quotient is always on the bottom here. This part, that part's the quotient. Okay. So if no terms were missing, right, there's 2 terms here. If no terms are missing and there's 2 terms, 2 coefficients at least, what is going to be our highest power? So remember when we're doing this, we have like squared, and then we have to the first power, and then we have a constant, first power. So I like to think of it this way. I know that whatever number is closest here, whatever number that's closest, that's my constant. That's my constant, right? You could work that way. You could work that way. What comes over after the constant? This direction. X. So this right here, this is called the quotient. And if I go over here now, the quotient I want to put in there, it's that 1x plus 7. Do I need to put this 1 out here? Nah. We're just showing that that coefficient was 1 plus 7 plus 4 over x minus 2. Okay. I know it's a process. We're going to do a couple of these in class in particular. Are there any questions coming up right now? Zarafa.
So if it wasn't in descending order, would you still go like constant x?
The quotient is always going to end up in descending order. If there was a 0, say for this value, then I would know that it would be, say if we ended up with, it's not going to happen, but if there's a 2 there and this was a 0, this would be my constant. The x to the first power is missing. 2x squared is from the 2. Okay, so that always works when you end up with a place value. That 0, you have to keep in mind that it's always in descending order. If there's anything missing, then the 0 goes there and you can leave it out. All right, thumbs up, sideways, down for these just quick examples like so. Okay. All right, that's pretty good. That's pretty good. Kind of here. All right. Should we do a subscribe? What should we do? It's Friday. It's anyone's birthday? Anything special going on this weekend? Parties? Math parties on 3? Good. Volunteer? Volunteer on 3? What? Why?
Well, I'm volunteering.
Oh, okay. Volunteer parties?
Yeah.
All right, volunteer parties on 3. 1, 2, 3.
Volunteer parties.
It makes no sense, but this lesson does.